Hi friends, this is Lean Reads, where big ideas meet practical takeaways, all distilled from great books. Imagine you're a character in a video game. The bartender's lines are all scripted, but when it's your turn, you get to decide what happens next. Do you stay, or do you walk away? That's the difference between being programmed and being truly free, and it's exactly what Kevin J. Mitchell explores in Free Agents. If you'd like to read the full book, the link is waiting for you in the description. Now, let's jump into it. Published in 2023, Free Agents by Kevin J. Mitchell is an ambitious exploration of one of humanity's oldest questions. Do we truly have free will? Instead of dismissing free will as a mere illusion, Mitchell presents a bold and compelling argument: free will, and it is the product of billions of years of evolution. The book takes readers on a journey back in time, beginning with the simplest forms of life, tracing the emergence of purposeful decision-making. Along the way, Mitchell examines how complex abilities such as imagination, self-awareness, and causal reasoning evolved abilities that allow us not just to react to the world, but to anticipate outcomes, shape the future, and ultimately take ownership of our lives and communities. This is more than a neuroscience book. It is also a deep dialogue with philosophy, physics, and biology, aiming to answer one of life's deepest puzzles. Are we truly the authors of our own destinies, or merely puppets pulled by the strings of physics and genetics? Mitchell's answer, grounded in scientific evidence, offers an optimistic vision of human nature. Kevin J. Mitchell is a neuroscientist and professor at Trinity College, Dublin. His career has focused on unraveling the complex interplay between genetics, neuroscience, and psychology. Beyond research and teaching, he is also a respected science communicator and author of the popular blog Wiring the Brain, where he shares insights into how our brains are wired and how they shape our behavior. Imagine stepping into the role of a character in a video game. You enter a bar, where the bartender, a pre-programmed non-player character, starts a conversation. Every line, every gesture he makes follows code written long before you arrived. Then, the game presents you with a choice. Sit and listen to his story, or turn and walk away. The bartender's actions depend entirely on your decision. In this scenario, you have free will, but he does not. He is nothing more than a bundle of scripted reactions. So, is free will real, or is it an illusion? This age-old philosophical question can be reframed simply: are we players making real choices, or are we scripted characters acting out lines we never chose? According to physicist Brian Greene, free will may be one of the greatest illusions of all. He argues that what we experience as making a decision is in fact already determined by the laws of physics. Our brains, like everything else in the universe, follow those same laws. Every thought, every action is the inevitable result of prior physical events. This deterministic view suggests the universe is like a vast machine, where everything from the Big Bang to your choice of morning coffee was always bound to happen. The future, in this light, is already written, and we are simply acting out the script. But before accepting such a bleak vision of human life, Mitchell reminds us of the complexity of the very concept of free will. Defining it is like trying to grasp smoke. Is it the ability to have done otherwise in the same situation? Or is it simply the felt sense that I am the one making this choice and carrying it out? This debate is not just a philosophical game. It has real consequences. Free will underpins morality, religion, and law. Without it, how could anyone be held accountable for their actions? How could praise or blame, justice or responsibility even exist? In Free Agents, Mitchell doesn't settle for abstract speculation. Instead, he tackles the problem through the lens of evolutionary biology. He takes us back billions of years, to the dawn of life itself, to see how evolution shaped organisms that didn't merely react mechanically to their environment, but grew into free agents, beings capable of shaping their own destinies. What is life? The battle against chaos. In a classic Monty Python sketch, a customer insists that the parrot he has just purchased is dead, while the shopkeeper stubbornly claims it's still alive. Though comedic, the exchange touches on a surprisingly profound question. Where exactly is the line between life and death? For physicists, the answer begins with a concept called entropy, the natural tendency of matter in the universe to move toward disorder. A rock can sit unchanged for millions of years because it is in equilibrium with its environment, chemically inert and stable. But a living organism is different. Life is, at its core, an ongoing battle against entropy. It is a fragile flame of order, constantly consuming energy to maintain its intricate structures while surrounded by a universe that forever drifts toward chaos. To keep up this fight, life requires a steady stream of energy. Today, we think of metabolism, the breakdown of nutrients, fueled by sunlight or food. But what about the earliest organisms, long before photosynthesis evolved? Where did they find the energy to persist? Many scientists believe the answer lies deep under the ocean, at hydrothermal vents, where simple organic molecules first tapped into the energy stored in proton gradients across mineral-rich surfaces. Then came a turning point, the emergence of cell membranes. Made of lipid molecules, these primitive protective bubbles enclosed chemical reactions and created a boundary between inside and outside, the first distinction between an organism and its environment. This was the moment individuality was born. Inside these delicate fortresses, more complex molecules like RNA and DNA eventually appeared. These were not just chemicals. They were blueprints, encoding instructions on how to maintain order and respond to environmental changes. The first self-replicating organisms divided and passed on beneficial mutations, laying the foundation for evolution by natural selection. Random mutation, combined with the relentless pressure of selection, kick-started the evolutionary engine. But from the very beginning, something crucial was already in place. Every component of a living system, from cell membranes to DNA strands, worked toward a shared goal, the survival of the whole. This was the first glimmer of purpose, value, and preference. A rock does not care whether it breaks apart, but a bacterium will do everything it can to survive. That drive to preserve its own integrity is the most primitive form of self-direction. And in that spark, we see the first building block laid on the long path that would eventually lead to free will. The first agents, sensing and responding living beings, are not passive spectators in the theater of their environment. They are active participants, dynamic agents constantly engaging, adapting, and striving to overcome the challenges around them. Even at the level of the simplest single-celled organisms, we can see the faint beginnings of autonomy. Take yeast, for example. It can adjust its metabolism depending on the amount of oxygen in its environment. When oxygen is plentiful, it performs aerobic respiration, producing abundant energy. When oxygen is scarce, it switches to fermentation. This flexibility represents a primitive kind of decision-making, a choice between survival strategies. But to respond, an organism must first sense. Over millions of years, evolution equipped life with an astonishing array of sensors, detectors for light, vibrations, chemical signals, and more. All of these tools serve one essential purpose: survival. And survival is not just about sensing, it requires movement. Organisms must move to find food, seek mates, and avoid danger. What began as random, aimless movement eventually evolved into taxis-directed responses to stimuli. A bacterium, for instance, can swim toward a region rich in sugar or away from a toxic chemical. Is this directed movement a conscious choice, or just a programmed mechanical reflex? At this stage, science shows us it is mostly the latter, genetically hardwired responses that don't require higher awareness. Yet, when we turn to communication, things grow more interesting. Even bacteria can talk to each other through chemical signaling, sharing information about food sources or toxins. This represents the earliest glimmers of intentionality, a rudimentary ability to shape behavior based on meaningful information, not just raw stimuli. As life evolved more ways to sense, process, and use information, it laid the groundwork for awareness and purpose. Eventually, organisms emerged with genuine priorities and goals of their own. At its core, this was the first step toward what we might one day call free will, a capacity that goes beyond sheer instinct. The rise of the nervous system. When brains began to record, the next great leap in autonomy was the invention of neurons. In multicellular organisms, coordinating the actions of billions of cells posed a daunting challenge. The nervous system arose as a sophisticated communication network, allowing an entire body to act as one. Picture a simple scenario. Light-sensitive cells on the skin of a primitive creature detect the shadow of a predator. The signal is sent through a central processing network, which then dispatches a command to muscle cells, causing the organism to contract and flee. This is just a reflex, yet already it shows remarkable complexity. The real breakthrough came with the appearance of interneurons nerve cells that created a pause, a gap between stimulus and response. Instead of reacting instantly to every sensory input, these pauses allowed organisms to integrate information from multiple sources and consider broader context before acting. This was the seed of deliberation, of choosing rather than merely reacting. The nervous system also turned inward. It monitored internal states, such as energy levels, issuing signals like hunger when resources ran low. From this foundation, more complex emotions emerged: rapid, value judgments about situations, good or bad, painful or pleasurable. These judgments became essential for weighing costs and benefits, a crucial part of decision-making. Another extraordinary feature of the brain was its ability to record experience. Neural connections could be shaped and strengthened by past events, creating memory. This meant organisms could learn from experience, rather than waiting for the slow grind of genetic evolution. Associative memory, for example, allowed creatures to link one stimulus with an appropriate response. If a certain plant always bore fruit after rain, the brain could remember that correlation, making future foraging more efficient. With these advances integrating information, cultivating emotions, and learning from experience, organisms were no longer tied to the immediate moment. They could act based on the past and anticipate the future. This marked a profound shift, from passively reacting to actively choosing, guided by inner reasons. It was a monumental step forward in the evolutionary journey toward will. Constructing reality, imagination, and the vision of the future. Philosophers often describe basic autonomy as the ability to perceive the world and respond accordingly. In other words, we act based on what we see and sense. But for complex creatures like humans, there is an added secret ingredient: a sustained awareness of self across time and space. As evolution progressed, our sensory systems grew increasingly sophisticated. Eyes, like finely tuned cameras, and intricate auditory structures, such as the eardrum, gave us a rich, detailed picture of the surrounding world. Yet raw sensory data is never enough. The brain is not a passive camera. It is an active artist, interpreting and constructing the reality we experience. Take vision, for example. What reaches our eyes are just patches of light and color. It is the brain, especially the neocortex, the hub of higher reasoning, that weaves these fragments into shapes, objects, and meaningful motion. Optical illusions dramatically reveal how perception depends less on raw input and more on interpretation, on the assumptions and prior knowledge the brain brings to the table. The same holds true for how we move and interact with our environment. The more actively we explore, the more we learn about space and the causal links between our actions and their outcomes. The brain functions like a grand cartographer, constantly drawing maps that connect what we see, what we do, and what we feel. Over time, this system became smarter, enabling increasingly complex and flexible behaviors. And from it emerged one of the most extraordinary abilities of all, the power to imagine the future. Our brains can simulate possible scenarios, project outcomes of different choices, and help us navigate toward opportunity while avoiding risk. When faced with a decision, we don't just react to the present. The brain convenes a kind of council, drawing on past experiences, memories, personal preferences, and even the emotional weight of imagined futures. Acting from this blend of past, present, and projected possibilities allows us to make deliberate, goal-directed choices. At this point, our behavior is no longer just reaction. It becomes authorship. This is very close to what we mean by free will. Breaking the chains of fate, quantum uncertainty, and two-stage choice. Classical determinism once painted the universe as a flawless clockwork mechanism, ticking away along a single predetermined timeline. But this tidy picture has been shattered by the strange revelations of quantum physics. At the subatomic level, the world is not rigidly causal. It is probabilistic, governed by randomness and uncertainty. Consider the famous thought experiment of Schrodinger's cat. A cat is sealed in a box with a device triggered by the decay of a radioactive atom. Until the box is opened, the atom exists in a quantum superposition, and so too does the cat, both alive and dead at once. Only when observed does reality collapse into one definite state, life or death. For free will, this has profound implications. It suggests the future is not a fixed script, but a hazy field of possibilities, more like a shifting cloud than a straight line. Each decision brings one possibility into concrete existence. A whimsical parable illustrates this. Buridan's donkey. A donkey, placed equidistant between two identical piles of hay, starves because it has no reason to choose one over the other. The absurdity lies in its paralysis. Sometimes survival demands a leap of randomness. Our brains, Mitchell argues, may tap into quantum indeterminacy to escape such deadlock. Neuroscience experiments deepen the mystery. EEG studies show that neural activity indicating a decision often arises milliseconds before we consciously decide. This has led to the idea of a two-stage model of choice. Stage 1, automatic. Fast, unconscious processes, habits, instincts, and learned associations propose one or more possible actions. Stage 2, deliberative. Slower, higher-order systems step in. Here, we evaluate the proposed options against our goals, values, and reasoning. Crucially, we retain the power to veto or approve. We can override instinct, choose against habit, and act for reasons beyond mere survival. In this delicate dance between determinism, experience, and instinct, and indeterminism, quantum chance, humans harness randomness as a spark of flexibility. But it is conscious reflection and deliberation that guide those sparks into meaningful action. Choices are not dictated by rigid chains of cause and effect, nor are they mere dice rolls. They are authored outcomes. And in that blend lies something very much like true free will. Self-sculpting, personality, choice, and autonomy. Even if we grant that human beings possess a measure of free will, this does not mean we have unlimited control. Our lives are always constrained by two great forces: nature, our genetic inheritance, and nurture, our upbringing, education, and social environment. Genes set the stage with innate predispositions, while environment and culture shape habits, values, and beliefs. But the deeper question remains: do we really get to choose the people we become? To answer, it helps to distinguish between personality and character. Personality refers to relatively stable patterns of emotion, motivation, and social style. It is deeply rooted in biology and culture, often emerging early in life. Character, by contrast, refers to the virtues, principles, and priorities that we consciously adopt to guide our behavior. Our identity, the personal self, goes further still. It is built upon the stories we tell ourselves about who we are. Each of us is a narrator, weaving past experiences into a coherent story of meaning. And here lies our most active role. We choose which experiences to highlight, which relationships to nurture, which knowledge to pursue. In doing so, we are constantly editing and reinforcing the story of our lives. This power of narrative allows us to reshape not only our character, but over time, aspects of our personality as well. Of course, personality sets the starting conditions long before self-awareness matures. But as we grow, we can consciously steer our development. The trajectory of free will begins in near total dependence, an infant subject to biology and circumstance, but gradually expands toward greater deliberation and autonomy in adulthood. Every time we resist a flash of anger, break a destructive habit, or act on reason rather than impulse, we exercise free will. We examine the roots of our emotions and rewrite the subconscious scripts that otherwise govern our behavior. In this way, we are not simply passengers, but sculptors of our own nature. Humans possess extraordinary abilities unmatched by other species. We can reshape the world, coordinate vast collective projects, and even reconstruct ourselves. Such capacities are hard to reconcile with the notion of a predetermined future. They point instead to a real evolved power of self-determination. Free will is not an illusion. It is a crowning achievement of the evolutionary process. The central lesson of Kevin J. Mitchell's Free Agents is that free will is neither a mystical gift nor a philosophical mirage. It is a biological capacity, painstakingly built up over billions of years of evolution, from the simplest metabolic reactions to purposeful action, to the flowering of consciousness and selfhood. Some reductionists argue that human choices are nothing more than the mechanical outcomes of physical signals in the brain. Mitchell shows why the truth is richer and far more beautiful. As life evolved, we moved beyond mere reaction to the environment. We developed future simulation, the ability to imagine and predict what might happen next. Self-awareness, the ability to reflect on our own thoughts and feelings. Moral agency, the ability to align actions with chosen principles and values. These powers cannot be fully explained without invoking the reality of free will. Human thought and behavior, with their capacity to restrain randomness and transcend instinct, allow us to shape character and direct action from a deep awareness of identity. Determinism alone, seeing the universe as nothing but clockwork, cannot capture this complexity. We are not puppets. We are authors. We are free agents. And what humanity chooses to do with that freedom is a story still unfolding. Reading Kevin J. Mitchell's Free Agents was both intellectually challenging and deeply rewarding. What struck me most was how the book bridges disciplines neuroscience, evolutionary biology, philosophy, and even physics into a coherent argument about one of humanity's oldest questions. Do we truly have free will? What I appreciated most is Mitchell's refusal to accept either extreme, free will as a mystical, supernatural gift, or free will as a complete illusion. Instead, he paints a more grounded, optimistic picture. Free will is not something handed to us from outside the natural world, nor is it a mere trick of the brain. It is something that emerged gradually, built step by step through evolution. As life became more complex, and organisms developed the ability to perceive, learn, imagine, and ultimately shape their futures. The metaphor that resonated with me was the idea of humans as self-sculptors. While our personalities and tendencies are influenced by genes and environment, we are not bound by them. Through conscious reflection, deliberate choices, and the narratives we construct about ourselves, we can reshape our character and redirect our lives. That message feels both liberating and empowering. What I take away from the book is a renewed sense of responsibility. If free will is real, not absolute, but genuine, then we cannot simply blame fate, biology, or circumstance for everything. We are called to use this freedom wisely, to shape not only our own lives, but also the communities and societies we inhabit. In the end, Free Agents left me feeling more hopeful. It reminds me that free will is not about escaping the laws of nature, but about working with them, about being aware, intentional, and creative in a world of constraints and possibilities. That realization makes me want to live more consciously, to value my choices, and to see myself as an active participant in the ongoing story of humanity. So, are we puppets of fate or genuine authors of our own lives? Free Agents suggests that we are more powerful than we think. The question now is, what will you do with your freedom?